You're listening to Science Coast with Mallory Havens
Chris White.
And I want to know now how potentially the Earth could end, like the physical planet could end, because I can talk about how life can be destroyed on Earth because I'm a biologist, so I study life. That's all I care about. But I'm also curious how the planet physically itself could go away, or the solar system.
So this is going to be a short conversation, and we're going to quickly switch to how life can end. It's incredibly, incredibly difficult to make the planet Earth go away. And there are one or two methods, but one of the examples that I want to give to illustrate how it'll be difficult to get rid of the Earth is to talk about how the moon actually formed and how people believe that the moon was
Can I
created.
tell you what I believe, which is probably wrong? So I think that an asteroid hit Earth and a chunk of Earth flew off, but not fast enough so Earth's gravity caught it and it became the moon.
Yeah, pretty clear. That's
good.
fairly accurate, except it was much more than an asteroid. They believe early in the formation of the solar system that there were planetesimals, and the primordial Earth and another primordial planet that may have been about the size of Mars. So two objects that were maybe about the size of Mars collided into each other. And so if you think about it, it was a hot mess.
Sure.
And material was flying in all directions. And in the process, some of that material coalesced into what we now call the Earth, and some of that material coalesced into what we now call the Moon. So it created a binary system. So when you take two things and basically smash them into each other, lots of different things can happen. And so then there were two centers of gravity that formed because there were two centers of gravity to begin with, and then there were two centers of gravity after. And then the coalescence of the material around those and then the friction associated with this hot mess allowed it to stay gravitationally bound to each other. And so that's what created the Earth-Moon system. So if two planets the size of Mars smashing into each other isn't enough to destroy the planet,
just makes a new planet.
It changes, right? So there is no asteroid out there that could possibly crash in and destroy the Earth. All it would do is basically kill everything that's on the surface of the Earth and then reform. You would get all of these different minerals and various, the surface, the plates and the surface would change, but the planet itself would just go, what was that?
So does the moon have the same molten core that the Earth has?
They're actually in the process of trying to figure that out. And the Japanese just sent a space probe specifically to try to answer that question, to do isotopic analysis of the atoms on the lunar surface to compare the isotopic concentrations with those of the Earth to see if there is evidence to show that they're basically the same thing or not. They were two independent objects. The theory is that there were two independent objects that collided into each other. So there could be evidence that would lead back to, say, two objects.
So it wouldn't necessarily be like the initial two Mars planets that collided wouldn't necessarily have the same elemental composition.
Not necessarily, but they would mix and potentially mix into a point where you wouldn't be able to differentiate them, but maybe not. And so there have been some studies that indicate that they can actually see in the mantle of the Earth remnants of of the original body.
Okay.
So the question is during that hot mess, did they completely mix or did they stay somewhat separate from each other?
Like a chimera.
What's that?
It's a chimera is when you have two fertilized eggs fuse and become one organism. So it's like the opposite of becoming twins in utero. You go from two individuals with different DNA into one individual that's some cells are from one embryo and some cells are from the
so
other.
Depending upon where you did the DNA test, you would get a different answer.
Correct. And that's based on the chimera it's called that because the chimera from Greek mythology, that's multiple animals combined together.
I would say that that's a good analogy.
Yeah, and that fits my bio perspective.
That's a very good analogy. So it's very hard to make the planet itself disappear.
Yeah, I guess. So the only way to do that is when the sun becomes like a red giant and then eventually gets so big it consumes the Earth?
Yes. So at some point after the hydrogen has been consumed in the core and the star begins to fuse helium into carbon, then the rate at which the energy is being created will accelerate tremendously, which will cause the sun to expand. And as the sun expands, the outer atmosphere of the sun will eventually reach the orbit of the Earth, and the Earth will then be absorbed into the sun.
Yeah, the whole reason I started thinking about this is because my 5-year-old son in school was learning about the solar system, and he came home one day and he said, "I don't want the sun to ever burn out." And I was like, "Oh, well, it's going to happen." And he was like, got really upset. And I was like, "Don't worry, you'll be dead way before that happens." At which point he started saying, "I don't want to die." So that's a great parenting moment for me. I was like, well, what are the other ways I can terrify him about how the Earth might end?
So going back to your comment about the asteroid striking the Earth, that is an interesting way to talk about humanity. Will life end or will humanity end is also another question, because we've had asteroid strikes which have caused mass extinctions.
Right.
But it hasn't extinguished life.
Right.
Life has always found a way to perpetuate and survive.
Do you know, okay, so I think it's pretty common knowledge that asteroid hit the Earth and like mass extinction of dinosaurs.
Mm-hmm.
Have you heard the modern theory, maybe it's been around for 10 years, about why the asteroid killed the dinosaurs?
Why? Because it fell to the Earth?
Yeah, well, okay, that part, but like what about it made them die?
I think it just changes the atmosphere. It changes so the atmosphere will have more particulate matter in it. There'll be an enormous fireball that spreads throughout the atmosphere potentially. For example, when they were doing the atomic bomb test in 1945, they were worried that they would ignite the atmosphere.
Ooh.
And that would end life on Earth. Or human life on Earth. So there's all kinds of things. It basically changes the environment. We talk about climate change being a very slow, subtle shift in the Earth's atmosphere and climate.
Right.
An asteroid slamming into the Earth is a very rapid
Climate change,
where you cause a very rapid change in the atmosphere, which then causes the living organisms in a particular region to not be adapted to the new climate that they immediately find themselves in.
Yeah, so I think they told my generation often that it caused a nuclear winter, and then like everything died. There was like a cloud, prevented sunlight, blah blah blah. But what I've learned maybe about 10 years ago is that so all this particulate went up in the atmosphere, and some of it went outside the atmosphere, but the gravity of Earth was strong enough, it pulled it all back in, and as things enter the atmosphere, they light on fire. And so as it was like coming in and all that,
I'm just looking at Mallory right now going, really?
And basically, this is a theory at least, that it ignited the atmosphere, essentially turned the atmosphere on the Earth to a broiler oven for a brief period of time. So like all the surface creatures were like, bleh. And then
they were roasted.
Yeah. And then 5 inches of soil provided enough insulation to not be roasted. So all the
bottom of the ocean.
Yeah, and the little burrowing animals, and which were like the original mammals which were around, and like plant seeds and everything were okay because they had that insulation, and they have evidence of in the fossil record that they can kind of narrow it down to even a season that it happened in. It was like I think it was springtime where the asteroid hit.
I caution that we need additional evidence to verify that that's true, because I've also read counter publications that the paper saying that this asteroid strike took place in a spring has some faults.
Oh, okay.
So it's not settled science. So I agree.
Nothing's settled science.
Yeah. So I agree that is a hypothesis and that is a theory. I'm not convinced that it's widely accepted as being true.
Okay. I just thought it was kind of interesting to think about the dinosaurs cooking.
Oh, absolutely.
I wonder how tasty.
So could you imagine? I know. So you come up out of your burrow and you're like, holy, look, banquet.
I mean, we already went from thinking dinosaurs had scales to knowing dinosaurs had feathers. So.
Yes. So there's a lot that we don't know yet. There's a lot yet to be learned. And so I think, my comment about a very rapid climate change and the specifics of that are in debate. But the fact that the climate changed instantaneously when the asteroid struck, I think, is not in debate.
Right. And I think that's a good way to explain it, too. We can't say necessarily with definity how it changed, but it did. Another way I heard life could end on Earth is a gamma ray burst.
So supernova is more likely, but gamma ray burst is a variation of a stellar explosion, and so near the end of certain stellar lives, you'll have a very energetic event. There are many different ways in which these events can be triggered, but the result is a very energetic, a large release of energy in a very short period of time. And there are certain types of these events, neutron mergers types things, where where two neutron stars, basically merge together to form either a black hole or something else. And in the process of doing so, an enormous amount of gravitational potential energy will be released over a relatively short period of time, which, due to rotational dynamics, can create what's referred to as like a beam of gamma rays pointing in a particular direction. So a lot of the energy can be concentrated and radiated as a beam of gamma rays. And if that beam of gamma rays happens to be pointed at the Earth, then you would have basically a large irradiation of the atmosphere, which would destroy the ozone layer, which could potentially then do radiation damage to everything that's on the surface of the Earth. So back to your point about everything on the surface being killed, but things that are underneath the ocean and buried under the ground being allowed to survive, the same thing might happen with a gamma ray burst.
So if the ozone layer is completely destroyed, would the planet deoxygenate? Would oxygen escape then?
Well, it's not that the oxygen would escape, but it would allow ultraviolet radiation from the sun to make its way all the way down to the surface of the Earth at much higher concentrations. And most living organisms are not designed to be able to deal with lots of ultraviolet radiation. Oh, the other thing about the idea of a gamma ray burst is that if you're on the opposite side of the Earth, so the side of the Earth that's pointing towards the gamma ray burst when it comes would get fried, but the other side of the Earth wouldn't.
Oh.
Because the Earth itself would absorb all the gamma rays.
Right, interesting. But if it destroyed the whole ozone layer,
correct,
then the Earth rotates.
Then you would and then you would have.
So you have like 6 hours to live.
Again, it's one of those where you'd have a very rapid change in the atmosphere, which would make it very challenging for many organisms to survive because you can't adapt fast enough to deal with the change. Right,
and then with considering deoxygenation, the vast majority of oxygen on our planet is here from photosynthetic organisms. Earth didn't come with oxygen. Life made oxygen.
I agree with that,
Earth.
Yes.
And so we're really dependent on this cycle where those of us who use oxygen release carbon dioxide, and those that release oxygen use our carbon dioxide, and we transfer back and forth. And so if something happened to disrupt that system and we're left with only photosynthetic organisms, or, they have mitochondria too. They can probably live without us. But if something happens where we have a lot of photosynthetic organisms destroyed, not only does it destroy our food chain, but it also prevents us from being able to breathe.
Yes, and thank you for bringing that up, because I'm not sure it's widely understood that oxygen came later.
Right.
And the oxygen content of the atmosphere is constantly changing and evolving, not on the scale of human civilization, but on geologic scale, absolutely. So, and there were periods in the past where the geologic record indicates that the oxygen concentration dropped precipitously, and that's also associated with one of the mass extinctions. So there's a mass extinction event at the same time that the oxygen concentration fell, and nobody's 100% sure, at least I have not been able to find any clear evidence to suggest this is what caused that change.
Yeah, and there was a mass extinction when oxygen first jumped up in the atmosphere because organisms didn't have enzymes and ways to prevent from reactive oxygen species. Oxygen is oxidizing and it's toxic. And so there was a mass extinction. They think maybe 96% of all species lost at the time where oxygen jumped up. And then through evolution, you got all these species. You're like, I'll use that.
So can I talk a little bit about this idea of an asteroid coming in and slamming into the Earth? Why would an asteroid at this point in time come slamming into the Earth? Because there's a large pool of asteroids out beyond Pluto.
The asteroid belt, right?
Well, the asteroid belt is between Mars and Jupiter, but then there's the Kuiper Belt and the Oort cloud, which is farther out past Pluto. Pluto is technically part of the Kuiper Belt. And
yeah, when it lost its status as a planet.
This region of the solar system extends out like really far. And as the solar system revolves around or orbits around the center of the Milky Way galaxy, it is moving in and out of spiral arms. We're not currently in the middle of a spiral arm, and the density of stars is much higher. So stars come towards the Earth, stars move away from the Earth. It is entirely possible that another star system could pass close enough that it gravitationally disrupts our solar system. And if a second star were to get close enough to the Earth, it could, for example, eject the Earth away from our sun, and we would be floating around in the galaxy all by ourselves.
We wouldn't get a new sun? We wouldn't join
Not
its
necessarily.
crew?
Not necessarily. So it is possible for a passing star to eject the Earth into basically deep space.
How dare it?
And that would probably end life as we know
for
it.
sure. What's at the center of the Milky Way?
Big massive black hole.
Oh, okay.
Like millions solar mass black hole.
Yeah, that's why the pictures of it always have a dark center. Got it. And with that, the views, thoughts, and opinions expressed are the speaker's own and do not represent the views, thoughts, and opinions of Lewis University. The material and information presented here is for general information purposes only. The Lewis University name and all forms and abbreviations are the property of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service, or sun. This podcast was produced in the WLRA Podcast Studios at Lewis University. Visit lewisu.edu for more information about Lewis. This has been Science Coast with Mallory Havens and
Chris White.
Thanks for listening.